Well, good morning, everybody. We're going to dive into the next section today, 1.6. We're going to be talking about limits at infinity and limits of infinity. And so let's dive in with a definition. I've gone ahead and wrote it out to try to make this a little quicker, but we say that a function f is, quote, going to infinity, and I'll typically write it like this sometimes. So it's going to infinity at a point A if f gets larger and larger as x gets close to A. And when I say larger and larger, I really mean arbitrarily large. I'm going to actually add that here. So I mean arbitrarily large. You can make f be as large as you want. On a similar note, we say f is going to negative infinity, which we'll just put a negative symbol there, at a point x equals a, if f is getting larger and larger, but the values are negative. So when I say larger and larger negative, I mean like negative 2, negative 3, negative 4, negative 5, so on and so forth. As x goes, as I said, as x goes to infinity. That's not what I meant. I meant as x goes to a. There we go. All right, well, let's dive in and do an example. So I wanted to look at this problem with you. We'll do it visually in a minute, but I want to think about it purely numerically first. So think with me. Let's start with some positive numbers, and let's think about little numbers that are getting closer and closer to 0. So for example, let's say f of x equals 1 over x squared for notation's sake. So let's look at f of 1 over 10. That's small. Well, 1 over 10 is, 10 squared is 100, so that's 100. That's getting quite big. And if I go f of 1 over 100, now I get, what, 4 zeros, so 10,000, and so on and so forth. And so as you plug in smaller and smaller numbers downstairs, then that actually flips it and makes it large. And the key is if you have something small like 1 over 100 downstairs, you just quite literally flip it up. I said 100, but I wrote 1,000, but you'll be okay. All right, so you can already see here, as x is going to 0, the bottom going to 0, the bottom getting small means the whole fraction when you flip is actually getting large. We need to be careful because we need to think about signs. Signs as in positive or negative. You can go to 0 from the right or from the left, and we need to be careful from the left. But the square here means it doesn't matter whether you plug in positive 1 over 10 or negative 1 over 10. When you square it, it's going to both go to 100. And so in this case, you can see, let's erase everything, you can see that this limit is actually going to infinity. All right, let's go ahead and graph a picture now so we can see even more clearly. I don't want you to rely on pictures, but I do want you to see in this case what's happening. So I'll change colors here. Hopefully you know the graph of 1 over x squared. It looks something like this, and then this similar thing on the other side. Okay, and since whether you go to 0 from the right or whether you go to 0 from the left, the function is getting larger and larger and larger. We're going to use the notation of infinity to capture this situation. So that's the first example. Let's do one more, and then we'll make a comment, and then we'll end the video. So for this example, it seems so similar. I'm switching from 1 over x squared to 1 over x, and the same argument sort of says, look, if we have g of x equals 1 over x, then you can see that g of 1 over 10 is 10. And so g of 1 over 100 is 100, and you can see now that I can make the output y however large I want by plugging in something small enough. If you want to get to 1,000,000, you just plug in 1 over 1,000,000, right? G of, well, let's do it, 1 over 1,000,000 is going to spit out 1,000,000. And any number that you want to hit, you just plug in 1 over that number, and you're going to get there. So clearly, the limit as x goes to 0, I am going to say from the right this time, of 1 over x. That's certainly infinity. But now let's think about what happens when I come from the other side. I'm coming from the right, blowing up to infinity. When I come from the other side, x is negative now. So think with me. If I look at g of negative 1 over 10, I get negative 10. If I look at g of negative 1 over 100, I get negative 100. And here, when I come from the left, I am getting arbitrarily large, but arbitrarily large negative. And so you can see that the limit as x goes to 0 from the left of 1 over x is actually minus infinity. And so these two things together, let's use a different color here. Let's use red. These two things together tell me that this limit, we would simply say, does not exist. Now, I want to make a comment about that. Let's actually squeeze a remark in up here. And this is important. So if we say that the limit as x goes to a of f of x, when we say that equals infinity, this means that the limit does not exist. There is no number that f is getting closer and closer and closer to, but it is getting arbitrarily large. So the limit doesn't exist, but f is getting arbitrary large. So when you say that the limit is infinity, it's understood that the limit doesn't exist. There's not a number that the function is getting closer and closer to. In this case, though, we can't even say that it's getting larger and larger, because if you come from the right, it's getting larger and larger, but if you come from the left, it's getting larger and larger negative. And so let's look at a picture here to help us see. I think we can squeeze in a picture of 1 over x over here. You should hopefully know what this function looks like, but just in case you've forgotten, it looks like this, right? You can see it on this side, and then it's over here on the other side. And now it should be clear to you. From this side, the function is blowing up to infinity. From this side, the function is blowing up down to minus infinity. And so we would say that the full limit doesn't exist, because it's not getting arbitrarily large on both sides, or arbitrarily large negative on both sides. All right, so let's end this video with a remark. I want to talk about the form of a limit. So a couple of things here. Let's go ahead and assume that I have a number c that's not 0. And let's suppose that when you work out your limit is of the form c over 0. And I'm going to show you an example of that. Let's scroll back up to this one. If I were simply to plug this 0 into this function right here, I'm actually I can't just plug it in because I'm dividing by 0, but just imagine that I could. I would have 1 over 0. Now 1 over 0 is undefined, and I want you to realize I'm never actually plugging in 0. X never gets there. X is getting closer and closer and closer to 0. And as it does, 1 over x squared is getting larger and larger and larger. But the form of this limit, just the form, is 1 over 0. And so that's the situation that I'm talking about. My c would be 1. So let's squeeze that in up here. The limit as x goes to 0 of 1 over x squared has the form 1 over 0. Now, again, 1 over 0 is a problem. That's undefined. But what I want you to realize is any time you have a form like this, 1 over 0, your limit is going to either plus or minus infinity. So the limit is either plus or minus infinity. And it's not enough to look just at c. You have to be very, very careful. The sign of the bottom and the sign of the top. Remember, the bottom isn't actually 0 when you're computing. I'll show you an example in just a minute where this matters. So just because the c is positive doesn't mean that the limit is positive infinity. You have to pay attention to the bottom too. So that's one form. Anytime you have a constant upstairs, or the top is going to a constant and the bottom is going to 0, then you know the limit is going to be either plus or minus infinity. Now, these limits, 0 over 0 and infinity over infinity, these forms pop up sometimes. And as it stands, these are what's called indeterminate. Let's write this down. These are what's called indeterminate forms. And I want you to think about this in two ways. What this means is that anything can happen. If the form is 0 over 0, the limit might be 0, it might be infinity, and it might be anything in between. And the same here, infinity over infinity, the actual limit might blow up to infinity, it might be 0, it might be something in between. And so what this practically means for you is more work. You need to do more work. When you see an indeterminate form, then you can't compute the limit yet. You have to keep working and do some algebra or some fancy tricks or things like that. So let's end this video here, and in the next video we'll work out some examples.